So the limit definition is given as follows: 0 less than absolute value x minus c is less than delta, then absolute value f of x minus L is supposed to be less than epsilon. Now, when I think, and let's just focus on the limit definition for starting here. So when I think about the limit definition, I think about what is inside of those absolute values is the target. So here inside the absolute value, I have x. So that means I'm looking at the target that I'm approaching for x is going to be c. And we talked about how in class that would be that absolute value, you would use the opposite sign. So the target here is c. And then what is on the right-hand side of the absolute value, this you can think about kind of as an error tolerance, where we have to be plus or minus away from that. So the delta here is going to be the error on the x-axis. Okay, so we have the opposite sign from what's inside the absolute value, that gives us our target, and then what is after the absolute value, the less than number, that is your error. So if you look at, for example, the conclusion, I should say, of the limit definition, we have f of x, which is the same thing, of course, as y, minus L. So that would mean that the target on the y-axis is equal to L, and the error would be this epsilon, so plus or minus epsilon. All right, so with that said, let's look at the problem that they've given us here, thinking about the target and what the error is going to be. So for the first part on number 182, they say that we want 0 is less than absolute value x minus 3. So that means that our target on the x-axis will be equal to 3. So we're approaching 3 on the x-axis. We know from our discussion that we're trying to find delta. So delta is going to be the plus or the minus away that error that ensures that we're within a certain epsilon of that target. All right, now over here, the f of x plus 1, remember opposite sign of what you see inside of those parentheses. So the y target is going to be equal to negative 1. Okay, so over here we see the negative 3, we say our target is 3. Here we see the plus 1, we say our target is opposite sign, negative 1. And then we do have a given epsilon here, so that tells us that our epsilon is going to be our error, which in this case is 1. So that tells us that on the y-axis, our error is plus or minus 1. All right, so we use this with the graph to find delta. So the whole goal here is to find our delta. So I'm going to scoot this up just a little bit here. So we're trying to find delta. And we kind of start from the back and work our way to finding delta. So we know that our y target on the y-axis is negative 1. Okay? We know that the error on the y-axis is plus or minus 1. So our target is negative 1. We go up 1 and then down 1 from that target. Now, if we continue this line vertically and then continue this line vertically, okay, all of those values will be within what we call our epsilon band or interval. So anything in this area here is going to be within that epsilon band. Now, we want to figure out what delta we have to choose, so what x error, essentially, we have to choose to stay within that epsilon band. So to do that, we will first have to identify the target that we have, which is 3. So that is our target on the x-axis. Now, moving from left to right, we want to see when we first enter the epsilon band. So we're not in the function. So again, this black function here is not in the epsilon band. Up here, it's not in the epsilon band. Here, it's not in the epsilon band. It becomes part of the epsilon band at 2. So we find the points of intersection. So this is starting at 2, and then it continues to be in the epsilon band until this point right here. Now remember, we are after our x value, so what we do is we go up to the x value and we say that it's 4. Okay, so the x values that correspond to staying in the epsilon band are 2 and 4. Now our target is 3. So if you look at from the target to where we start the epsilon band, that is 1 unit. And if you look at where the target to where we end the epsilon band, that is also 1 unit. So that tells us to take our delta to be equal to 1. So the process here, just to summarize, is that you identify what your target is and what your error is. You draw your epsilon band, and then you find where that intersects with the graph. So that was this whole thing about finding 2 and 4. And then from that, you identify your delta. So your delta will be, again, the smaller value. In this case, they were the same. But if this had been 1 and this had been 0.5, we would be choosing 0.5. So it's always the smaller number if there is any competition between the two.